This is section 6.5, where we're going to be graphing other trig functions. We've already graphed sine and cosine. Today we're going to graph the other four. We're going to graph secant, cosecant, tangent, and cotangent. Now I'm aware that these are not necessarily something you've seen before, but we have had some experience with secant and cosecant and tangent and cotangent before. So let's just bring back a few things that we remember. We know, and by the way, please notice it says no calculators. Remember, the rest of this chapter is no calculators. So when we look at the secant graph, and I say, what is the secant the reciprocal of? You know that secant is the reciprocal of cosine. That means that secant is 1 over cosine of theta. It's a reciprocal. We're going to be flipping something. So identify the function below, which is starting at a high point, going to a middle, low, middle, high. So let's mark our single period of the graph. And what do we have right there? What does that look like? Looks like the cup. This is y equals cosine of x. Now I went ahead and I marked down some values for the cosine values from the graph, looking at the table of values. This is just looking at our cosine values from our unit circle. If secant is 1 over cosine, if secant is the reciprocal of cosine, remember that the reciprocal of 1/2 would be 2. The reciprocal of 1 is 1. The reciprocal of 1/2 is 2. What's the reciprocal of 0? That's undefined. It doesn't exist. So at 90 degrees, right here, where it crosses the midline. You see where my graph crossed the midline? I have an undefined. This is -2, -1, -2, and I have another undefined where it crossed the midline again. So everywhere that this graph crosses the midline, I'm going to draw an asymptote everywhere, all throughout the graph. And if I were to plot these points, -62, let's go -60 degrees, that's about a third of the way right here, up to +2, 0, 1, 60 degrees, +2. Do you see that this graph is actually sitting on that sine curve? But what happens at asymptotes? Think back from several chapters ago when we were graphing with asymptotes. The graph approaches the asymptote without actually touching it. So it's the flip. If you look at this graph right here and we flip it over, we would end up with the secant curve. Well, what about this side? This is at -1. The reciprocal of -1 is still -1. But the reciprocal at 120 degrees is at -2. And the reciprocal at 240 degrees right here is also at -2. So this is going to curve down. And that makes one full cycle of secant. Imagine the center is gone, it's not there, and all you can see is this parabola-looking shape, one pointing up and one pointing down. That's one period of secant. It still takes 360 degrees. Now I know you're looking at it going, but wait, 360 is over to here. So what if I did that part right there? Would you see from 0 to 360 that those two together make one full parabola pointing up, and there's a parabola pointing down? That's a graph of the secant curve. Now we could keep going, we could keep drawing. All we need to do is match our maximum points and our minimum points. They match up and they flip upside down. So if this is down here, it's going to point downwards. If this is above the midline, it's going to point up. So where is this one going to point? It's below the midline, so it will point down. When we look at that, we can recognize everywhere that secant was undefined was anywhere that sine of theta is equal to the midline value. Anytime it was equal to the midline value, secant will be undefined. Now in this particular graph, that was at 90 degrees, 270 degrees, 450 degrees. How far apart are those? Those are 180 degrees apart. So our domain is going to have an asymptote. It's going to be all real numbers with an asymptote at 90, then another 180 degrees later, then another 180 degrees later. So you need to look at this and recognize that there are some asymptotes, and where they occur is everywhere that sine of theta approached a midline. What will happen to the graphs when cosine equals 0? We get an asymptote. Whenever we had, I'm sorry, I completely messed that up. It's not sine, it's cosine. When it touched the midline, in this particular graph, when the cosine of theta was 0, we got an asymptote. Anytime it approached the midline, we got an asymptote. Cosecant works the same way, except it plots off of the sine curve. See the sine curve? It starts right here, rises. There's one cycle of the sine curve right there. Well, everywhere that the sine curve touches the midline, everywhere the sine curve touches the midline, do you see that this has moved over? It's shifted. It's not in the same locations because the sine curve and the cosine curve are shifted over as well. So this didn't happen at 90, 270, and 450. This happened at 0, 180, and 360. But it's still 180 degrees apart. And so this graph is going to look just like the secant curve, except it's going to be shifted to match its reciprocal. It's going to be shifted to match the reciprocal graph. So we've got secant. The secant graph is built off of cosine. See my cosine curve right there? Secant is built off of cosine. Cosecant is built off of sine. There's the sine curve, and cosecant is built off of that. It takes a full up and a full down to make one period.